If a hypothesis is conducted using alpha equals 0.05, for which of the following p-value would the null hypothesis be rejected? Explain. First, let's state the rule for the p-value approach. It states that if the obtained probability is less than or equal to the alpha level, we must reject the null hypothesis. Otherwise, if it is greater than the alpha level, we must accept it. So let's take a look at A here. It is 0.3. Since our alpha level is 0.05, this makes it greater than the alpha level, therefore we must then accept it. For letter B, our value here is 0.06. This is greater than our alpha, therefore we must accept the null hypothesis. Our C here has a value of 0.243. Since this is greater than our alpha, which is 0.05, we must then not accept the null hypothesis. For our letter D, we have here 0.1. Since this is still greater than 0.05, which is our alpha, we must then accept the null hypothesis. And lastly, we have our letter E here. Our value here is 0.001. This is lesser than the alpha, which is 0.05. Therefore, we must reject the null hypothesis. Moving on to letter B, for each pair of alpha level and p-value, identify whether the null hypothesis would be rejected. Explain. Applying the same general rule, which is if the value is less than or equal to the alpha level, we must reject the null hypothesis. If it is greater than the alpha level, we must accept it. Alright, so let's take our values here. For letter A, we have here an alpha level of 0.05 with a p-value of 0.10. Applying the rules here, we must accept the null hypothesis, since our p-value is greater than the alpha level. Next up, to letter B, we have an alpha level of 0.05 and a p-value of 0.05. Since our rule states that if it is less than or equal to the alpha level, we must reject it. Therefore, we must reject the null hypothesis for letter B. In C, we have an alpha level of 0.01 and a p-value of 0.001. Since 0.001 is less than 0.01, we must then reject the null hypothesis for letter C. Next up, letter D, we have an alpha level of 0.01 and a p-value of 0.10. Since 0.10 is greater than 0.01, we must accept the null hypothesis. And lastly, we have an alpha of 0.10 and a p-value of 0.01. Applying the rules here, we would have to reject the null hypothesis.
Here we have item number 2. Solve and explain the following. In letter A, in a test in which the null hypothesis states that the population mean is equals to 80 against the alternative hypothesis which states that the population mean is less than 80, the sample data yielded the test statistic z is equals to 1.63. What is the p-value for the test? For letter B, in a test in which the null hypothesis states that the population mean is equals to 80 against the alternative hypothesis which states that the population mean is not equals to 80. The sample of observations had a sample mean of 81 and standard deviation of 4.1. What is the p-value for this test? Now, in order for us to solve for letter A, here we have our given values. Now, according to our z table, here we have the z value of 0.4484, which we then subtract to 0.5000, which is then equals to 0.0516. And since this is a one-tailed test, we will multiply 0.0516 1, which then equals to our p-value, which is 0.516. Now, in order for us to solve for letter B, here we have our given values, and since we don't have the value for z, we will solve for it using this formula right here. We will then substitute the given values to their corresponding variables and then simplify, which is then equals to 2.18, and according to our z table, our z value will then be 0.4854, which we will then subtract with 0.5000, which is then equals to 0.0146. And since this is considered to be two-tailed, we will multiply 0.0146 to 2, which then equals to our p-value, which is 0.0292. That is all for item number 2. Thank you.
Item number 3, we have a politician claims that she will receive 60% of the votes in the upcoming election of a random sample of 200 voters. There were 100 who will surely vote for her. Test the politician's assertion at the 0.05 level of significance. For the given, we have p sub 0 equals 60%, or 0.6, n equals 200, x equals 100, and our alpha is 0.05. For step 1, we have to describe the population parameter of interest, which is the population proportion p sub 0. For step 2, we have to formulate the hypothesis. Since P is equal to P sub 0, then the null will be P is equal to 0.6. Then our alternative hypothesis will be P is not equal to 0.6. For step 3, since the sample size is n equals 200, therefore it is large enough to apply for the CLT. In step 4, we will be choosing a significant level size for alpha. The test is two-tailed. Since there is no significant level size for alpha, therefore the test is two-tailed. For step number 5, we will be computing for the z statistic, which we will therefore be using the z formula right here. But before solving for the z statistic, we will first find the value of p hat, which therefore we will be dividing 100 over 200, which results to 1/2. And for the q sub 0, we will subtract 1 minus our p sub 0 or 0.6. Back with the formula of our z statistic, we have our p hat 1 over 2 subtracted to 0.6 over the square root of 0.6 multiplied to 0.4, which is our q sub 0. Solving after and over 200, after that, we have the answer of negative 2.89. Since we are computing for the z statistic, we will convert negative 2.89 to the value in the z table, which is 0.4981. That results to 0.0019 after subtracting 0.5000 to 0.4981. Since we have a two-tailed test, we will multiply 2 to 0.0019, which is our answer here. Then we will get the answer of our p-value, which is 0.0038. Step 6, for the decision rule, directly we will reject the null if the computed probability value is less than or equal to 0.05. Then to our last step, where we compare the computed values. Our computed value here is 0.0038, which is our p-value. It is less than 0.05. The null, based on the decision rule, the null is rejected because the computed values is less than 2 or alpha 0.05. Therefore, there is significant difference between the sample proportion and the population proportion.
Number 4. A social worker reports that 30% of the workers in a factory are below 15 years of age. Of the 120 employees surveyed, 38 said that they were below 15 years old. Using an alpha equals 0.05, interpret the p-value. First, we must describe the population parameter of interest. The parameter of interest is the mean of the population where the sample comes from. Our null hypothesis is p is equivalent to 0.30, while our alternative hypothesis is p is not equal to 0.30. Is the sample size large enough for the CLT to apply? Yes, since n is equal to 38. Is the test one-tailed or two-tailed? The test is two-tailed. Next, we must compute the probability value. First, we must solve for p hat. Using this formula, we will have a p hat of 0.3167. Next, we must solve for our z value. We must use this formula for the z value. With this, we would get a result of 0.3992 for our z value. Next up, we must solve for our p-value. Our p-value would be 0.6897. We also have an x of a value of 0.105. Next, we must state the decision rule. Reject the null hypothesis if the computed probability value is less than or equal to 0.05. Do not reject the null hypothesis if the computed probability value is greater than 0.05. Lastly, we have a computed probability value that is greater than our x, which is 0.6897. With this, we must fail to reject the null hypothesis.
So in problem number 5, we have this problem. The principal of a school claims that 30% of grade 3 pupils stay in the playground after their classes. In a survey, among 500 grade 3 pupils revealed that 150 of them stay in the playground after their classes. Use 95% confidence to conduct a test of proportions. So our confidence interval here is 95%, and our n here is 500, and our variance here is 0.30, and our QA here is 0.70. So to get our answer, to arrive into our answer, we will use this formula. So to substitute it, we have 0.3 plus or plus minus is 1.96 and square root 0.3 times 0.7 over 500. So we have a answer of 0.24 and 0.34. So it arrives to 0.24 less than p less than 0.34. And that's all.